One thing that's really important to understand in physics and actually in math as well is the difference between a scalar and a vector, and then by extension eventually learn about other kinds of values. So both of these are types of values, they're types of numbers that can exist. And so when we talk about first is vectors here. So all forces are known as vectors. And this is because they have magnitude and they have direction. So there's an amount and there's what direction it's pointed in. So magnitude is the amount, how strong the force is, right? You can have a weak or a strong push, and so we measure that amount, and that's our magnitude. And this is usually a number. And then the direction is the direction it's pointed. That the direction is which way the force is pointed. And this is usually represented with an arrow or the plus or minus sign. So if I say that I've got a force that is negative 16 newtons, that means it's 16 strong, 16 newtons strong in the negative direction, whatever direction that ends up being for the problem that you've set up. So that's what a vector is. It's something with magnitude and direction. Scalars, on the other hand, are quantities with only magnitude. So if it only has magnitude, it's a scalar. If there's only amount, if it doesn't make sense to define a direction, it's a scalar. So some examples of vector quantities, we'll talk about these as we get on. Displacement. So if you move something from one place to another, the measurement of how far and which direction you moved it is a vector. Velocity, which we'll talk about later, but that's basically how fast and which direction are you traveling. And then acceleration, which is how much are you changing your speed and in what direction. And then lastly, of course, we've already talked about them, but you've got forces. So these are all vector quantities. Scalar quantities, examples of scalar would be position. So where is something? It doesn't make sense to say something is at 0.5 that way. It's just it is at 0.5. Time. It doesn't make sense to say you are at 5 seconds east or 5 seconds north. You are just at a point in time. And then speed, which again, we'll get into these later, but speed is basically just how fast something is going. It doesn't care about which direction it's traveling. So that's some examples. As we get into the year and we talk about and we use more vectors and scalars, it should kind of make more sense as you see them. Let's talk about vector math. So when adding and subtracting vectors, you need to consider both the magnitude and the direction. So you need to care about how much and which way it's pointed. So for example, if I have the vector A like this, pointed that way, and the vector B pointed like this, then A plus B would be that combination. But if I have the same A, but now I make B negative, meaning I point B in the backwards direction, then A plus B is only this distance here. Or if I have an A like this, and a B like this, the sum would be this diagonal here. So the way that you add vectors is you basically line them up. You lay down the first one, then right at the end of the first one, you lay down the second one, and then you connect the starting point to the ending point. So we lay down the first one, right at that point we lay down the second, and then we connect where I started to where I ended. These should actually be right on top of each other, like A, B, but then it gets kind of hard to see, so that's why I layered it. And then here you see that we do A, and then we do B, and the sum is just connecting the starting and ending points here. When you add two forces together, this is known as the net force. Or if you add four forces together, it's still the net force. It's basically when you add up a bunch of forces, the total is the net force. And this is represented by the Greek letter sigma followed by an F. So this right here means net force. And we say sigma F if we want to explain like what the actual symbols that we're writing are. So that's an introduction to forces. Again, we'll spend much more time on this as we go forward. But if you have any questions, let me know.